So as promised, last video I actually say that we have to do a question. So just to make it more clear, so I actually decided to do 1B of the exercise 6 pitch 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 64. Okay. So apparently it's 2yx plus dx to x square y plus sine 3x dy. So this is the question. It may be equals to 0. It is definitely equals to 0. Okay, anyway. So okay, so what we're gonna do first is to check your m and set your m and n. So this will be your m and n. Let's put this as m and this is n. Okay. The second step is to check whether is it exact or not. So how do you do exact or not? Okay. As I said earlier, if it's in terms of dx for m, you differentiate in terms of dy. Okay, you differentiate in terms of dy. Okay, so therefore you'll get let me see 4xy plus 3 cosine 3x. Okay, so this is n, this is y, and then for n itself, okay, in terms of x, because opposite variable, because the intuition behind is to, because this is in terms of dx, so therefore if m dx dy you compare to m dx dy, because exact means that this is equals to this, therefore is equals to 0 right? So this is what it means. So you want to eventually find this and then see whether are they exact or not. If they are not exact, that means they are not equal. So this whole system is that this should be equals to this in any case, and therefore let's do it. So if you were to partial in terms of x, you will get let me see, I have 4xy plus 3 cosine 3x. So apparently you can see that they are exact. Okay, so this is actually the first step. Okay, check for exactness. Alright, so the second step is to, now we put away the thing, we put away all this, is already history. So now you can solve for this, or you can solve for this in terms for the xi, for the original equation. We want to get a glimpse of the original equation. Okay, so now I just try this. So in terms of xi, maybe I just, so xi equals to m. So I partial m dx, which is equals to let me see, 2xy square plus. Okay, now this is a problem. Now you have 3y cosine 3x, which is okay, anyway, let's try, see how first. Because yeah. So if I were to differentiate now dx, it will be x square y square plus cosine, if you integrate it should be sine. So it's 3 sine, okay, sine 3x, and then multiply by 1/3. So it will be y sine 3x. I may be wrong. Okay, I just see the answer is correct. It's part of the answer is correct. 3x. And then plus, since you are differentiate in terms of dx, okay, so you have something in terms of dy, right? You have something over here that you're unsure, maybe because this is equals to this, but however, let's say um, n is equals to a plus b plus c, and then n is equals to a plus b, and maybe maybe a is equals to a plus d, where um where d contains some b plus c, that thing. So you want to find where d equals to b plus c. Okay, so apparently if you were to find the original equation, you realize that part of the answer in n uh didn't reveal in m. Okay, this part I always cannot reveal the good information about. Okay, so it's some function of y plus x. Okay, some function of y, we don't know what the fuck is that, but this is actually the xi. Okay, the xi. Wow, what the hell? Okay, the original equation. So with this original equation, now you differentiate in terms of y, because you want to solve whether are there any things that we are lack of. Okay, so later you can see. Now this is the comparing method, I would say lah. Okay, comparing method. Uh, so if you were to partial xi in terms of partial y, okay, just take note that if whatever thing is, because if you are now because you integrate m in terms of x, and then you get the original equation, which is free of dx and or dy, and then now you differentiate in terms of y, okay, to find the, because and in mind, this is already your final equation. Okay, this is already your final equation. Just that you have some function of y you need to solve for. That's why we want to solve for the function of y. And in order to assess the function of y, we need to compare with the actual function of y over here, which is n times dy. It's a little complicated, but I hope you get what I mean. Because I also don't get what I mean myself. Yeah, okay, I'm just talking rubbish. So sin 3x, and then plus f prime 1, and then c you differentiate is just 0. So you eventually get this equation. So let's copy this portion. So you'll see that this is the n, right? So this is the n. Now if you were to compare x squared y plus 3x sine 3x plus function of y, you realize that the function f prime 1 is actually equals to 0. Okay, because there's nothing. If let's say you have some plus 3, then definitely f prime 1 equals to 3, and then you can solve for whatever function. But now you can see that there is no extra function, so therefore f prime 1 is equals to 0, and we can conclude that our final equation is this is the xi. Okay, this is what our xi we actually solve for. But however, since we know that the f prime 1 equals to 0, therefore the function of y is also equals to 0, and this is why we put it here. And this is the final answer. Okay, and then don't go yet. Okay, let's do the alternatively method. Okay, alternatively method. Maybe we can see some things. Actually no lah, because yeah, never mind. So let's just stop here first, and then yeah, because this is two variables. However, what I want to convey is that there is a few careless, not careless, but things that you need to take note over in this question is that you the first thing you need to know is whether how do you integrate, okay? How do you differentiate or integrate? How do you check for exactness? Check for exactness, normally you check you differentiate in terms of the opposite variables. Okay, this is one thing that I realized, which is must be remembered one. And then after you check the exact, and then you integrate in terms of whatever dx over here, because you want to clear away your dx or dy. Therefore, this is the glimpse of your original equation. A glimpse, okay, a glimpse of your original equation. It's just that this is your original equation. You already have the answer already. This is the answer. But however, you have this function of y, which you don't know what the fuck is that. So you need to solve for the function of y. So in order to solve for the function of y, you just differentiate in terms of y, so that you have this equation, and then you compare it with in terms of the somewhat the function of y, the dy portion of the equation. So therefore you finally solve for it. So what do you mean? So apparently let me see. So let's say, so what does this whole thing exact means is that how, let's say if you were to have this equation, okay, let's say you have this equation psi. Okay, let's do a reverse engineer. Okay, if you were to partial xi partial x, okay, because typically if you were to remember, when you solve this type of problem, partial differentiation, you're solving equals to some answer, right? Equals to the final answer of d xi to differentiate function of xi, right? If you want to differentiate this equation, you need to partial differentiate from x, and then you partial differentiate y also, and you add them together, right? Okay, so apparently this is what it is. So this is why if you were to partial differentiate in terms of x, you get this form, and if you were to partial differentiate in terms of y, so okay, this whole equation you partial differentiate in terms of x, you get this one. Okay, if you were to partial differentiate the whole thing in terms of y, you get this one, and then you get the whole equation. I mean, you get the whole differentiated equation, which is this form. Okay, so I hope it clears out all the doubts. I know I didn't clear your doubts lah, but I clear partial of your doubts. So yeah, see you. Hey, hold on.